Hello everyone. So we have come to the last question of the Group B of electric drives question paper for the year 2024. So the question is, draw a neat circuit diagram of a four-quadrant MOSFET chopper drive and explain regenerative control. So left hand side figure is a circuit diagram of a four-quadrant MOSFET chopper drive. So in this figure, wherever it is written CH, that means it represents a MOSFET chopper. So there we can see we are having four MOSFET switches and four diodes. These diodes are freewheeling diodes which are connected across each switches. So for CH1 we have D1, for CH2 D2, for CH3 D3 and CH4 D4. So and there is a load EMF E and L. Current through the output is I0 and voltage across the load is V0. Source current is represented as IS and source voltage as VS. So this is the circuit diagram. So to understand easily this circuit, we are having a VI, or you can say VI characteristics or four quadrant representation. So in that we are having, in the x-axis we are having the output current, and for the y-axis we are having the output voltage. So in case of the first quadrant, when CH1 is operating, CH1 is turned on, that means this switch is turned on. So the current will flow through CH1, then it will come here through load, it will flow through CH4 and it will go back to source. So as it is written over here, first quadrant CH1 will operate. So CH1, CH4 will be on at the same time. So when CH1 turns off, then CH4 current will pass through CH4 through D2 back to source. So for a small duration. So this is the operation of the first quadrant. In the second quadrant, what will happen? CH2, that is switch 2, will be turned on, and along with that uh, D4 will be there, where inductor will store energy. When CH2 is turned off, then D1 and D4 will conduct. In case of the third quadrant, CH3 is operating. CH3 and CH2 are turned on. CH3 is off, then CH2D4 will conduct and E is reversed. Polarity of the load EMF is reversed. Similarly, for the fourth quadrant operation, CH4 is operating, CH4 to D2. In that time, the inductor will store energy, CH4 will turn off, then D2 and D3 conducts and E is reversed. So we will have a short overview of the four quadrant chopper. This is also known as a H-bridge chopper. So four quadrant chopper is also known as a H-bridge chopper. It allows bidirectional current and bidirectional voltage. That means in the third quadrant and the fourth quadrant, we have seen that it is written E is reversed. So we are having in the first quadrant and the second quadrant positive E, and the third quadrant and the fourth quadrant negative E. So we are having both way voltage. Similarly, we are having um, bidirectional current. So these are all covered in the torque speed plate. Like quadrant 1 will go for forward motoring, quadrant 2 for forward regenerative braking, quadrant 3 for reverse motoring, and quadrant 4 for reverse regenerative braking. So as per the question, we have to discuss the regenerative control in four quadrant chopper. So first we have to know what is regenerative braking. Regenerative braking means we have the process by which the returning energy means process of returning energy. From where? From the motor back to the supply. Instead of wasting it in the resistors, we are feeding it back to the source. So regenerative braking means we are having some energy from the motor. That energy we will be returning back to the supply instead of wasting it. So we are having the regenerative control in quadrant 2 in the form of forward regeneration. In that case, the motor is running forward, but speed is higher than the no load speed which has been set by the chopper. What will happen? Motor back EMF will be more than the supply voltage, that is V. So motor will now act as a generator and current still flows in the same direction, but the voltage will reverse. Switches in the chopper CH2 and CH3 are controlled so that current is routed from the motor to the supply, because in case of regenerative control the main motive is feeding back the source, feeding back the energy from the motor to the supply. So energy from the rotating motor is fed back to the source. The fourth quadrant also shows reverse regeneration. So motor is running in the reverse direction, but we want to slow it down. So what happens? The back EMF will exceed the supply voltage, but in the reverse direction. So now switches CH1 and CH4 will be triggered appropriately in order to fulfill its motive, that is feeding back the energy from the motor to the supply. So braking will occur when energy is being recovered. What are the advantages of regenerative control in 4-quadrant chopper? First of all is the energy saving, as energy, it is being returned to the source. Instead of wasting it in the resistors, that is heat dissipation is not done, so energy is being saved. Second is smooth braking, precise control via duty cycle adjustment. Third is a bidirectional operation. So one pair of one's MOSFET will be uh, working in both forward and reverse braking. It is high efficiency, that is ideal for applications in frequent acceleration and braking like electric vehicles, train, lifts. So all this were the answers related to the group B. I hope it was clear to you. Thank you so much.